Hey there, welcome back to the channel. In today's video, I will be teaching you how to incrementally do data processing with SQS queue and the new Amazon S3 table buckets. Anytime new files are added on Amazon S3, we're going to be setting up an event so that those events are captured into an SQS queue and the messages are nicely buffered into that. And then the Spark job is going to poll the Amazon SQS queue after a particular poll interval. It will grab the S3 URI, and after grabbing the S3 URI, it is going to read that as a Spark data frame and then performs a merge into new Amazon S3 table buckets. The whole exercise, you can do it locally. So let's get started. All right, so the first step is go ahead and make sure you clone the repository locally. I've already done that. And the next step is we need to create an SQS queue. Remember in the architecture over here, right? Anytime a file is dropped, right, those events are captured into the SQS queue. So we need to create an SQS queue, and I have a very simple shell file which will create an SQS queue. So what we'll do is come to your terminal, chmod, let's do chmod +x /create SQS, and I'm going to run this command. And you should see a queue URL being printed on the console, as you can see. So my Amazon SQS queue has now been created. So if I probably go to my SQS, come here, refresh, and as you can see, I do have a sample data processing queue. All right, so the next step is we need to create a folder called raw, which is where we'll drop our files. So I'm gonna click on create folder, and I will call this folder raw and click on create. As you can see, I have a sample folder which has nothing inside that. Now let's go to properties, scroll down until you see over here, I already have one. So let me go ahead and delete that. So under event notification, we're gonna click on create event notification, and I will simply give the prefix as raw. This is important because we only want to capture events happening in that particular directory. And I'm gonna click on all objects and then scroll down. You will see SQS queue. Then select from the drop down the queue that we just created. Then click on save changes. So now you have configured the particular event. So in the diagram, what we have done is we have a folder raw where new files will be dropped. We configured an event. As soon as a file is dropped, the S3 URI will be published to the SQS queue. And then of course the Spark job will poll the queue and write into the new Amazon S3 table buckets. Okay, so make sure you have done these steps with me. All right, so the next step is you need an Amazon S3 table buckets, and you can head over to the management console, click on create table buckets, give it a unique name and click on create bucket. I already have that, and this is the ARN. So make sure you go ahead and create an Amazon S3 table buckets. All right, so now we are going to drop some sample data files to see if everything works together, right? So in the same project repository, you have a 2 sample CSV file, and simply drag into this particular folder raw. I'm going to click on upload. As you can see, 2 files have been inserted. So what I expect is when I go to the SQS queue, I should see 2 events. So now if I head to SQS, I refresh, and I can see 2 events over here. That is fantastic. You can verify, of course, by send and receive, poll for messages. And if you click here, you should see that particular S3 URI. As you can see, I can clearly see my event that has been fired over here. Okay. So now the next part is we need to run the PySpark job, which should poll this particular SQS queue and write into the Amazon S3 table buckets. All right, so let's take a look at the job, and I made it super easy. It's a config driven job. So let's take a look at that. So I just have 3 things, right? Spark input output. Spark is where you would define your Spark configuration key value. And the only thing that you would have to change is on line number 9. Here you can see my table bucket ARN. You will replace that with your table bucket ARN in the code, right? The rest is standard, right? I don't think I need to explain. Input is basically an Amazon SQS, right? You can see the queue URL, right? Queue URL. Poll interval you can specify based on your needs, right? Protocol is going to be S3A because we are running it locally, right? So I'm going to be using an S3A, right? So what this will do is in the code, if when it polls the messages, right, the S3 path starts with S3, right? Since you want to run it locally, it will replace S3 with S3A, okay? But on EMR and EMR on EC2 and EMR serverless, S3 would work just fine. Output simple, right? Schema. So the particular schema for the iceberg table, because when you are running it for the first time, the iceberg table does not exist. So here you will see an Avro schema, right? Very simple, right? And then merge query, that is the merge SQL, right? So as you can see, simple merge SQL. All we do is we dedupe the incoming messages by using row number, And then if it's a match on the primary key, which is invoice ID, if it's a match, update everything. If it's not a match, insert everything. It's as simple as that, right? So again, entire job is simple config driven, right? Now it's time we have to run this job. And first you will set your Amazon AWS access, secret, and the bucket. And then you'll just run the job, Python 3, the Python file, and then you will pass in the config file. You see how easy it is, right? So I've made it very easy, right? A simple config driven job, right? So all I have to do is simply pass the config file and make sure you change the particular path, right? And now we are about to run the job. So I will run this particular job now by providing the config file. So let's run. As you can see, the job has started. At this point, it should be polling the Amazon SQS queue. And if it finds any particular messages, this should read that as a Spark data frame. Looks like it got that particular message from the Amazon SQS queue, read as a Spark data frame. And here you can see the info log. It did execute the merge into command, right? As you can see, and the consume message has now been deleted, right? As you can see. So it's been working fine, right? As you can see. So if you go to the particular code, I mean, again, the code is quite generic. All it does, it takes the config file. Once it reads the config file, it creates a Spark session. And then you have a while true loop, right? Where you basically call for messages. You grab messages from the Amazon SQS queue. If there are no messages, you just simply print that, hey, there are no messages. If you have messages, you invoke the function process message, where you pass in the message, the Spark object, the input payload, and the output payload. And once the message is consumed, if the checkpoint is set to true, you basically commit. So basically those messages are deleted from the Amazon SQS queue, and the process will repeat after your polling interval that you have defined, right? So it's literally that easy, right? So yeah, I hope you have enjoyed this particular video. So, of course you can try this out locally. You can run it on your machine. So I would say I would really encourage you to try these labs out. And if you have any questions, let me know in the comment section below, and I will try my best to answer that. Until then, all I would say is keep smiling, keep programming, and I will see you in the upcoming next video.